All right, let's look at example 113. Use the difference formula to simplify sine of 90 degrees minus x. All right, so sine of 90 degrees minus x. Let's go back up here and grab the formula. For the sine of a difference, we've got this. Copy, then down here, paste. Try it again, paste image. There we go. So you don't need that. Move this over here out of the way. All right, so there's the formula we need. So sine of 90 minus x is equal to sine of, okay, this is unfortunate because it's 90 minus x, and this over here is x minus y. So I'm going to call the 90 my x, and my x is going to be my y. So this is going to be sine of 90 degrees cosine of y, which is x, minus cosine of x, x is 90, sine of y, and y gets replaced with x. All right. So let's see, sine of 90 degrees is 1. Cosine of 90 degrees is 0. So what we get here is just cosine of x. So sine of 90 degrees minus x is cosine of x. And if you think about it, we really already knew the answer to this. This is just sort of using this identity to come about it. But you know, if you have a right triangle, if this angle over here is x, I don't even have to call it degrees, just x, then if we label our sides here A, B, and C, this angle up here, this angle is 90 degrees minus x. Let's call this angle A, and this one up here B. We already know that sine of 90 minus x we already know that's equal to the cosine of b, because both of these, like if you look at the sine of 90 minus x, it's going to be the opposite over the hypotenuse. And if you look at the cosine of angle b, it's the adjacent side over the hypotenuse. And of course, opposite and adjacent swap when you go from one angle to the other. So anyway, that's just a way to sort of verify that formula. All right, let's look at this last one. Alpha and beta are both in quadrant 3. Sine of alpha is negative 2/5 and cosine beta is negative 3/4. Find sine of alpha plus beta and sine of alpha minus beta. All right, well, let's see. So sine alpha is what we've got to do. Sine of alpha plus beta and sine of alpha minus beta, both of those involve sine and cosine of alpha and beta. So let's look at this for alpha. We're in quadrant 3. So this is our reference angle. And the sine is opposite over hypotenuse. And so this third side over here is going to be, let's see, 25 minus 4. This other side here is going to be root 21. It's going to be negative. So that tells me cosine of alpha is minus root 21 over 5. Similarly for beta, beta is also in the third quadrant. So if I draw that in, beta, cosine beta is negative 3 over 4. So that means adjacent is negative 3, hypotenuse is 4. So this other side is going to be let's see. Might be tempting to say 5, but this isn't a 3, 4, 5 triangle because 4 is the hypotenuse, not the other side. So let's see, this is going to be 16 minus 9 is 7. So this other side over here is negative square root of 7. It's negative because we're in the third quadrant. So let's see, cosine beta is negative 3/4. Sine beta, I'm going to move this so I can put the sign underneath. Sine beta then is negative root 7 over 4. So that right there is really half the work of doing this problem. The other half is plugging into these formulas for sine of a sum and sine of a difference. So let's come up here and copy these formulas that we need. I'm going to paste those here. All right. So let's see, sine of x plus y. That's going to give me, well, sine of alpha plus beta is sine alpha. Cosine beta, maybe I should write that in. Sine alpha cosine beta plus cosine beta. Wait, no, that's cosine alpha sine beta. So let's see, sine alpha was minus 2/5. Cosine beta was minus 3/4. Cosine alpha is minus root 21 over 5. Sine beta is minus root 7 over 4. So let's see, what is that? 6 over 20 plus, notice all this stuff becomes positive because we've got two negatives multiplied on both of the terms. So let's see, 21 times 7. Notice this, if you multiply root 21 times root 7, you get root 21 times 7. You can rewrite that as 3 times 7 times 7. So it becomes 7 root 3. So you get 7 root 3 over 20. So 6 plus 7 root 3 over 20. All right, now let's do sine of alpha minus beta. Sine of alpha minus beta. Let's see, I'm going to come back up here before I do this, and I'm going to write them in here. Alpha, beta. So the x's are becoming alphas, and the y's are becoming betas. So we get sine alpha cosine beta minus cosine alpha sine beta. So let's see, sine alpha was negative 2/5. Cosine beta was negative 3/4. Oh wait, it's the same except for the sign in the middle. This is going to be minus instead of plus here. Cosine alpha was root 21 over 5. Sine beta is root 7. Wait, I'm going to go back for a second. We've got the minus here, which is from the formula. Then cosine alpha itself is minus root 21 over 5. Sine beta is minus root 7 over 4. So we wind up with, let's see, this becomes positive 6 over 20. This becomes negative, because we got 3 minuses, 7 root 3 over 20. So maybe I did a lot more work here than necessary. because this answer winds up being the same as um, it winds up being the same as this one up here, except for just the plus changed to a minus. All right. All right, that's the last example here, and that's pretty much all I'm going to ask you to do in this section is to do some problems where you're having to apply these formulas. So that's it for this section.